All right, so let's take a look at some theorems. We're going to learn about some theorems today. So you can see there is a chord here, and these two angles are subtended from that chord. They are on the circumference, and those are always congruent. Also, if the chords from the same circle, if they have the same length, so if there's another chord somewhere else that has the same length that is congruent to this chord here, it will also have the same angles on this arc. Okay, so here we have a case where we've got this chord here, and then we've got these two angles coming from that chord that are on the arc. Those must be congruent, so we're going to use those principles to solve that problem. Okay, so these are notes, but then I've got a small example here that you can do just to kind of understand the concept. Here we've got, this is called a central angle, and obviously it comes from the center of the circle. And then from that same chord, if we were to connect those here, this is an angle on the circumference. Now, the rule here is that the central angle is always 2 times the angle on the circumference. Okay, so we can use that principle to solve this problem here in our notes. We're looking at 6 theorems today. Next theorem is dealing with cyclic quadrilaterals. So this is a quadrilateral that all the vertices touch their circumference here. Okay, now the rule here is that opposite angles are always supplementary. So for example, if this angle was 100, that means that this angle would have to be 80, and so on and so forth, and you'll use that to answer the example. Okay. Next theorem is pretty simple. It's related to the previous. We've got a central angle of 180. Well, we know that circumference, the angle on the circumference is half of that, so it's 90. And so it's stemmed from the previous theorem, and it's always 90 degrees. And when we know that the triangle formed is 90 degrees, we can use Pythagorean's theorem. So we know that this angle here is 90. The next theorem, a radius to a tangent is always 90 degrees. And that's pretty intuitive because we know that the nearest distance from a point to a line is always perpendicular. And that would have to be the nearest distance. And we can use that to answer this question here. So we know that this is 90 degrees. So how are we going to find out the missing side? Well, we're going to have to use Pythagorean's theorem on that. Okay, what I have here, I have 4 questions, and some of these require multiple steps. Okay, so you're going to go through and you're going to talk about, okay, look at the scenario here and then decide how you're going to solve the problem. And you're not only are you going to solve the problem, but I want you to include the theorems that you're using, all the theorems that are used in order to solve the problem. So there are 6 theorems that we can quote up here.